Welcome to Corporals Corner. Today we're talking about basic land navigation, and we're going to keep it simple, so stick around. Alright, today's the day. You asked for it, and you're finally going to get it. We're talking about basic land navigation without a map. And truth be told, once again, that I've steered clear of the subject for the main reason of it's an overly saturated market. And what do I mean by that? Simply Google or YouTube how to use a compass, land navigation, etc., etc. You're going to come up with thousands, tens of thousands of videos. Everybody and their mom has done a video on land navigation. And my question is, how do I reintroduce something into a market that's overly saturated? And it sucks, but the truth be told, once again, you can't do it. You just can't compete with someone who has 700, 800,000 subscribers. And yes, I have 130,000 subscribers, but the chances of them watching my video over theirs would be purely accidental. They're going to take it, file it to the bottom, and if you see it, you see it. Now, there's a lot of work involved in this, and that's why I've kind of been standoffish and taken the back seat. There's also several good series out there. Dave Canterbury has 3 or 4 different series on this. Coldcracker Bushcraft has a series he put out a few months ago. Even Black Hat Bushcraft just did a 7-part series. So I suggest go check those out, because you're guaranteed to learn something. Now, as far as my channel goes, what I'm going to do, since I haven't done this, I'm going to go ahead and try to keep it simple, dumb it down to just the basics, and we're going to walk through my preferred compass, parts of the compass. Then I'm going to show you how to shoot an azimuth, bearing, reverse azimuth, or back azimuth. Get a pace count. We're going to talk about waypoints, and even plotting the route. Let's go ahead and get started. Let's go ahead and kick this off with the 3 types of north. We have true north, grid north, and magnetic north. Because this is a basic land navigation class, and we're not using maps, we're only going to refer to magnetic north. Now, let's talk about true north. Think of true north as north in relation to the Earth's axis, okay? Where the North Pole is. Grid north. Think of a map, okay? We have grid lines. Now the northerly direction of those grid lines will give you grid north. That's why you always want to orientate your map north before you use it. And finally, last but not least, we have magnetic north. And that's the direction of the magnetic needle on your compass. Okay, so now that we understand that we're only dealing with magnetic north, let's go ahead and move on to types of compasses. Currently on the market, we have 2 types of compasses that are being sold. One's a lensetic compass, the other is a base plate compass, like this one right here. Now, an example of a lensetic compass would be, those of you who are former military remember the old school metal or aluminum Kamenga compasses. They're bulletproof, bomb-proof. I actually watched one fall off of an LAV or light armored vehicle, hit the ground. I believe it got ran over. The Marine jumps off, picks it up. Why? Because gear adrift is a gift. Grabs it, opens it, dusts it off, checks it, and he was back in the game. Okay, so for those of you who are fans of that type of compass, stick with it. Don't try and fix something that's not broken. However, with that said, now that I have several years of experience under my belt, I've fallen in love with these base plate compasses, simply for the fact that it's multi-use. There's several options on here that will make my time in the field, and yours as well, a hell of a lot easier. Let's go ahead and check it out. So here we have our basic Suunto MC2. Starting here at the top, we have our signal and sighting mirror. It can be used for hygiene purposes as well. You could take that mirror and use it to look at areas on your body that you can't normally see, looking for bites, scratches, ticks, etc. Moving down, we have our rotating bezel ring. Now on that bezel ring, we have a series of numbers. Those would be your degrees for your azimuth or bearing that we'll talk about later. Inside of our bezel ring, we have our magnetic needle. And you can see how sensitive that is. Just from contact with this pencil, it's moving around. So that's good to go. Red means north, black is south. The red will always face north. Now, perpendicular to our magnetic needle, we have our orienting arrow. sometimes referred to as a doghouse or a shed. Someone will say, put red in the shed. So all you got to do is rotate your body with your compass, put the red end of that needle in that shed, or that dog in that doghouse. Now on our bezel ring, we actually have, or right below it, we have a glow-in-the-dark line here and here. Now think of the Back to the Future analogy. This one on top up here will tell you where you're going. The bottom one will tell you where you were. So that will be your bearing or azimuth. That will be your reverse azimuth. The bottom of our compass here, we have a clear plastic base plate, why it's called a base plate compass. We have a series of scales. And my personal favorite, we have the magnifying lens or sun lens for starting fires. Now that we understand the basic parts of our compass, let's go ahead and move on to azimuth and bearing. Now the terms azimuth and bearing go hand in hand, and they mean the exact same thing. All it refers to is the degrees on our bezel ring, like I mentioned before. So to shoot an azimuth or bearing, all we're going to do, plug in, say, 40 degrees into the top glow-in-the-dark indicator on my compass. And from this point right here, I can rotate my body, which moves the compass, until that dog is in the doghouse or the red's in the shed. Pick a point out there in the distance, and I know now I can walk that straight line on an azimuth or bearing of 40 degrees until I reach my point or my final objective. So we have 40 degrees dialed in here at the top. All we're going to do, rotate our needle, put the dog in the doghouse or red in the shed. Now we can walk that azimuth or bearing of 40 degrees. Now for the million-dollar question. Why shoot an azimuth or bearing? Here's a simple answer. To walk in a straight line. Walking that straight line will help you avoid something called lateral drift. Now, lateral drift occurs for everyone a different way, but what tends to happen is people, as they walk, they tend to drift towards their dominant side, whether it be the right side or the left side of their body. They'll drift in that direction. And check this out. Over a long distance, you're walking a straight line, lateral drift occurs, and where you think you parked your vehicle, you end up over here, and now you're lost. Now it's time to shoot an azimuth or bearing. So all we're going to do is take our compass, go to our bezel ring. We'll stick with the number 40 because we already talked about 40-degree azimuth. Dial in 40 degrees, the top glow-in-the-dark indicator on my compass. I'm going to partially extend my arms out, keeping the base plate as level as possible. I'm going to go ahead and take my signal mirror and bend that down to about a 45-degree angle, or enough to where I can see the reflection of the bezel ring and magnetic needle. At this point right here, what I want to do is I want to go ahead and rotate my body, not the compass. Rotate my body, that will rotate the compass. And all we're trying to do is put the dog in the doghouse or the red in the shed. At this point right here, there's one more feature I want to talk about. At the bottom of my signal mirror, we have an opening. There's also a V-notch. Treat that V-notch like a gun sight. Keeping the dog in the doghouse or the red in the shed, I want to take my eye, and the compass should be at eye level. I want to peer through that V-notch or gun sight and find the target out there in the distance. Let's say, for example, I see a tree. That tells me that I can walk freely on a bearing or azimuth of 40 degrees until I hit that tree. I should run right into it. At that point, all I got to do is move to the opposite side of the tree, shoot a bearing or azimuth again of 40 degrees, And that will keep me moving in that straight line. Here's my start point. Our 40-degree bearing or azimuth. And here's our tree. I can then move to the opposite side of that tree, take my compass, locate a new target, and continue walking at 40 degrees in a straight line. All right, you're doing an outstanding job. We've gone out there, we've explored for the day, we walked on an azimuth or bearing of 40 degrees, now it's time to go home. How do we do that? We're going to shoot a reverse azimuth or back azimuth. So all we're going to do, use one of the features of our Sunto MC2. We're going to look down. We have our two glowing indicators. I look down at the bottom one. The top one tells me where I was going. The bottom one tells me where I was. The bottom one says 220 degrees. All we're going to do, spin that bezel ring, dial in 220 to my top glowing indicator, and repeat the process. Get my compass level, my arms partially extended, move my mirror so I can see the reflection. Now rotate my body, which will move the compass. Get that red in the shed or the dog in the doghouse. Move my eye to my gun sight, or the gun sight to my eye, keeping it level. Pick a new feature. I see a tree out there in the distance. Now I can walk home. And for those of you who are using a lensetic compass, I'll show you how to find your back azimuth. All we're going to do, take our azimuth that we were currently walking, and made sure we walked in a straight line, and that was 40 degrees. We're going to use the acronym LAMS. Less than 180, you add 180. More than 180, you're going to subtract 180. So we ask ourselves the question, we're walking 40 degrees. Is 40 degrees more or less than 180? It's less than 180. So all we're going to do, we're going to add 180. And that comes out to what? 220 degrees. There's your back azimuth. Let's go ahead and move on to keeping track of distance as we walk. Now we went out there, we shot our azimuth or bearing at 40 degrees. I want to be able to walk out there, turn around, shoot a reverse azimuth, and come right back to my starting point. So how do I do that? Well, the simple way is with a pace count. And a pace count is just what it says. You're counting your paces, or you're keeping track of your paces as you walk. And to do that, what you're going to want to do is step off with your non-dominant foot, which is for me to be my left foot. And every single time my right foot touches, I'm going to count. So what I'm going to do is I'm going to go ahead and step off with my left foot. And every single time my right foot touches, I'm going to count. Here we go. 1, 2, 3, 4, 5, 6, and so on and so forth until I reach 100 meters. Now to keep track of your pace count accurately, you need to select 3 separate locations. The first one's got to be flat, level terrain for 100 yards or 100 meters. Next, you want to locate some type of hill. Start at the base of that hill and walk at a 45-degree angle to the top of that hill. And lastly, using that same exact hill, you want to start at the bottom or the base of that hill and work your way towards the top for 100 yards or 100 meters. Now, each one of these locations, you have to walk it twice, meaning from your start point to the end and then back to your start point. That will give you 2 separate numbers for each one of these. You want to take those 2 numbers, add them together, and divide by 2. That will give you your average. At the end, you're going to have 3 separate numbers. You're going to have a number here, and a number here. You will then add those 3 numbers and then simply divide by 3. And that will give you an average number for your pace count to simulate rough terrain, up and down hills, skirting a hill, going down into a ravine, etc. So there's my start point, and 100 meters take me all the way down here. $60. Now, determining how far you've walked is quite simple. You can go ahead and make tick marks on a paper for every 100 meters or 100 yards that you walk. You can bend down and pick up a small pebble, put it in your pocket. You can carve notches on a stick. Or you can use something called ranger beads or pacing beads. Using ranger beads or pacing beads is quite simple, and there's several different variations of this, but the ones that I prefer have 4 beads at the top, and these represent 1,000 meter increments for a total of 4,000 meters. Now at the bottom down here we have 9 beads, and they represent 100 meter increments for 900 meters. It's very simple. For every 100 meters or 100 yards that you walk, all you're going to do is drop 1 bead. 200 meters, 300 meters. It's very simple. Now let's say you've gone 900 meters and you walk an additional 100. You're at 1,000 meters. So all we're going to do at that point, drop one of our beads from the top and return our 9 beads. Now we can go 1,100 meters, 1,200 meters, 1,300 meters, all the way till we get 1,900 meters. Drop our second bead, return these beads, and start off at 2,000 meters, 2,100, 2,200, and so on. Let's continue moving forward. We've established that we can shoot an azimuth or bearing. We then can get our reverse azimuth or back azimuth. We can establish a pace count and even keep track of that pace count. Now let's move on to obstacles. We got our pace count, we're shooting our azimuth, we're walking along. Everything's cool. All of a sudden, there's a large body of water or a swamp right in front of us. How do we negotiate that obstacle, meaning get around it, and end up back on our azimuth on the opposite side of that obstacle? Here's the answer, a 90-degree offset. Now a 90-degree offset is exactly what it says. You're shooting a series of 90 degrees to negotiate that obstacle or get around it and end up back where you started on the opposite side. So let's say, for example, we're walking along on an azimuth or bearing of 0 degrees. Rotating my compass to 90 degrees, either left or right, will give me anywhere from 270 or 90. So rotating for a 90-degree angle is 90 degrees. Now from here, keeping track of my pace count, let's say it's exactly 200 meters. Once I pass that obstacle, I can then turn my compass back to my original bearing, which is 0, until I've passed that obstacle. Once I've passed it, all I've got to do, rotate it for another 90 degrees. 90 was this way, so from 0, the opposite direction is 270. And I'll walk the same distance for 200 meters. And that should put me exactly the same spot on the opposite side of that obstacle. Then I can reshoot 0 degrees and continue on. Now, the last thing I want to talk about before we wrap up this segment is something called a waypoint. Now, a waypoint is basically an intermediate point or stopping point at which a route can be changed, or a fallback point, so that you don't get lost. And we try to simplify that. Let's say we go back to what we talked about in the beginning. We have our azimuth or bearing of 40 degrees. We saw in the distance a tree, and let's just say we walked to that tree for 500 yards or 500 meters. Once I got to that tree, I want to continue on. Put my back to the tree, reshoot 40 degrees. I happen to glance over and I see some type of water source or materials a couple hundred yards away. Now, a lot of people will wander down there and then hope they can find their way back to where they were at, use their compass, and then they find out they veered off so many degrees. So a waypoint is a simple way to find your way back. All we got to do is take some type of bright colored cloth. Could be a shamag, could be a bandana. In this case here, it could be an actual signal panel from the Hidden Woodsman. Two by 2 signal panel. All I'm going to do is I'm going to hang this at that tree that was in line with 40 degrees at eye level. Now what this does, it gives me the freedom to roam around as far as I want in any direction. As long as I can turn around and see this, I can come back to it. I can pick up my gear, put it back on, put my back to that tree, grab my compass, reshoot that 40 degree azimuth or bearing, and continue on in that straight line. So here's our start point. We're walking along for 500 meters. We hit our tree. I look over here and I say, oh, look it. Here's some water. All I got to do, I can either wrap the tree with my signal panel or simply hang it off of a branch. And now I can roam anywhere around here. As long as I can see that signal panel, I can go right back to it, pick up my gear, put my back to this tree, reshoot my azimuth or bearing to 40 degrees, and continue on. Welcome back. Land navigation is outstanding. Just my humble opinion. Now, the last thing for you to do is go ahead and plan some type of route. And I've given you all the tools to do that. Just go to one of your favorite locations, establish some type of starting point. Could be a parking lot, could be your truck. Simply, at that point, shoot your bearing or azimuth. And walk it for X amount of hundreds of meters. 200, 300, 400, 500, whatever you see fit. Stop there. Practice doing your 90-degree offset. And again, walk that until you're tired, a couple hundred meters. Once you're there, 90 again. If you're keeping track of your pace count, these numbers here should be the same. And these numbers should be the same. And from there, that will take you home. You can even go a step further. Once you get to this point, toss up a waypoint. Venture out as far as you can see. Come back, continue on. Another waypoint. Venture out as far as you can see. Point number 3, another waypoint. Venture out as far as you can see. Come back to your truck, do the exact same thing. And what you've done is you create a box recon. You've applied these tools. Now, here's what I'm going to do. If I get a good response on this video, meaning a lot of views, a lot of thumbs up, I'll go ahead and take it to the next level. We'll walk an actual land nav course, or what I'll do is we'll think outside the box and we'll up the bar and I'll combine map and compass. But I'm going to leave this up to you guys. If you want to see that, let me know. Hit the notification bell, subscribe button, and as always, thank you for your comments, views, support. Thanks for watching. Get out in the field and have some fun. I'm going to catch you next time.